I believe we are ready. We are ready to start the lecture for today. So what am I going to talk about today? Android security. That's what I'm going to talk about. We've hit a lot of more application concepts. I'm also going to hit motion and activities and notifications and stuff like that coming up soon as well. But for today's agenda, the concept of security is the focus of what we're doing. And just to take a look here to see what we're going to look at is Android applications in terms of setting the security, what we've seen so far, setting permissions basically. Security enforcement, security refinements, and then lessons on defining policies, security related things associated with mobile development. This is strictly Android based though. It doesn't really apply towards the iPhone development environment. And talking about Android application kind of examples of things that you're looking at, we have all sorts of different communication channels, and the communication channels are what is basically the focus of security in terms of adding permissions. If you know so far, if you've used the internet, you have to give internet permissions. If you're using the SD card for file system, you have to do that. For Bluetooth, you have to do that. For everything you could possibly imagine, there's a setting that you have to do. And it's usually in the manifest in the XML configuration file. And that's really what's called the sort of the configuration or the policies that are being set. And so it's more of a concept versus a brand new programming thing. You should be familiar with it so far. In this particular application, as an example, just to run through some of the different things we haven't seen so far yet. I haven't looked at broadcasts yet, broadcast receivers, or we haven't looked at notifications. We've looked a little bit at content providers. We definitely have looked at activities. So in this particular example, it's a location sensitive, sort of a social media. It's a find your friends application. It's very popular out there on the market actually, where you can track, it's a friend tracker application. So what does that require? It requires a lot of security. And in fact, it requires a lot of opening up the phone to allow for a breach of security, because not only do you need the internet, but you're going to need GPS, and you're going to need broadcast receivers, intents, and probably, lo and behold, content providers, and all these different things that basically are another component that you add. And if you haven't noticed it yet, you can actually check on each one of your apps. If you go to the phone and look at the Manage Applications section and look at the apps itself, it'll tell you what type of security features are set and what's not set. And by default, everything is pretty much turned off. When you install apps, you're turning things on. So the ability to read and write to the SD card, the ability to broadcast, send messages out, have the application actually communicate for you, send messages out, ping other people, track your location, do all sorts of different things. You think about if this were a computer, you'd have a million viruses at one point. you would have issues associated with it, because all of this stuff is pretty much it's made for the mobile community, but doesn't have very much security in mind when you turn it all off. So what we're looking at is a sample application of a social networking for mobile phones. It used to discover their friend locations. It's kind of like there's another one out there, Where Are You or something, or Where Am I or something, where it's like the people tracker. Like, you put it on, you have this app running, and it's broadcasting out your GPS location, and it's broadcasting out, how many calls you've made, or what kind of text messaging you're doing, or who you're connected to, or something. I don't know. It's information about you. So activities provide the user interface as we've seen so far, and we have two kind of things here. This is friend tracker and friend viewer. In terms of, let's say if we had two separate activities perhaps, or two separate screens. We have, let's say, a boot receiver, a friend tracker service running, let's say, from a content provider, a friend provider, which is going to be sort of like a contact list or something like that, activity itself, provider. The friend tracker controller, if we look at this from a model view controller perspective, would be the activity of the friend tracker. And then on the friend viewer, it's basically viewing, so the activity would be a friend viewer with a broadcast receiver and an activity for friend tracker. An activity for friend tracker would be running this activity on the viewer, because they have to communicate with each other. So services, execute background processing, as we've seen so far. And if you ran a service on there, you wouldn't have the app open up all the time. So for example, you want to be part of this friend tracking network, and you're going to load this on your mobile device, and it's going to run all in the background. So it's going to run as a service. So what we have is, again, a threaded type of environment where we have a background process or service that's running, that's sending out information about us, essentially, so that people can track us. The content providers are data storage facilities. The broadcast receivers act as mailboxes for messages from other applications. So we have those broadcast receivers also working with this. So take Friend Tracker as an example. What are some of the security things to kind of look at in terms of the design of this type of an application? Friend Tracker, the service pulls the external service to discover friend locations. So the service is constantly pulling. It's kind of like how your email service runs. You don't have to go. In the old days, you actually had to go, new mail. You click that new mail button and you updated your mail. Now it's the other way around. Now it's pushed to you instead of pulled, and it's a background service that's doing the pulling. And then the friend provider is a content provider. Maintains the most recent geographic coordinates of your friends. In fact, there's a very similar app for this for the iPhone as well that does the same thing. Just can't remember the names of them right now, but the concept's been around for a while. Friend Tracker Control, which is the activity, defines the user interface for starting and stopping the tracking functionality. So the controller itself is going to broadcast or not broadcast, track you or not track you, or go look for other, or start another. Let's say, for example, the activity could bring up, using an intent, start another activity to go view, let's say, for example, find viewers, find friends. And then boot receiver is a broadcast receiver that gets notifications from the system once it boots, and so that working with the notifications, the application uses this to automatically start a friend tracker service. So once everything is booted, upon boot, you can actually kind of take that notification and says, hey, we're booted up, and then start the friend tracker program service in the background. So basically, you don't even have to worry about starting the app. And this app here is probably the worst security app I could think of in terms of an example. It opens up, not only does it take the notification that your computer has booted, the boot receiver notification that comes through, starts a background service that opens up everything practically, and starts tracking you and sending information out to other people. So not what I'd call a secure application. So let's talk about the components and the interaction between these components. And that's not to say this is a bad one. This is a really good one. This is kind of a good application in terms of functionality. But in terms of security, not such a good example of good security. A good security program would be something that didn't do anything, actually. But how much fun is that? Not too much fun. So component interactions here. So the concept of the intent. So it's the primary mechanism for component interaction. We've seen an intent example where we had one screen or XML interface call another one, call another one, call another one through a class that was associated. So the class itself in the onCreate method comes up, creates the resource of that interface, loads it up, shows it to the user. You click something on the user, presses or clicks something on the user interface, a button or something. It creates an intent. So the new intent is used to essentially switch between this, it's all within one application, but switch between this class that's associated with this XML file and switch it over to another one. And so the example I gave you was that one that went from intent A to intent B, and there was a button on it that said this is intent A, or it probably said hello and the other one said world on it or something. And it switches back and forth. Most common way, actually, of intercommunicating between windows. It's kind of like how an application itself would load up sub-windows, but these aren't sub-windows. You can actually stop the previous application, close it, freeze it, finish it, and then the new intent that would call it would have all of the resources and would have full control over the activities that were currently going on. So simply a message object, and by definition, containing a destination component address and data. You can pass data, as we've seen so far already, from one window to another window using the intent by It's a simple pass through the creation of the intent. The action. So we also have an action, which is the process of the intercomponent communication itself. It's part of the configuration. So if we started looking at this, we would have the interaction between the components for which the components of the system application interact. From a component level, the system server would be over here. For example, this would be an internet location. And friend tracker would call the location manager, and the location manager would track the location, retrieve the information back. Then these would be considered broadcast intents. And then we would have other intents to read or write data, to look at or find friends on a map, and all sorts of different components essentially that are interworking to make this functionality possible. And here's another perspective of it. Each component itself supports interaction specific to its particular type in terms of the broadcast intent versus the other intent, so other reads and writes, or communication. So the service component supports the stop, the start, the bind actions. So friend tracker activity can start and stop the friend tracker service, and the service essentially is going to run in the background. So even if you have what you don't want to do is create it's the same thing on an operating system, create a background process that's running as a service and not be able to start and stop it. Then you have basically it runs all the time until you remove the service somehow. But in this particular case, if you use the activities to start and stop the service, you have a little bit more control over it. Turn it off or something. So security. What do we got here? Android project application at a system level. So it has the intercomponent communication, which is the ICC, which is basically describing this. These are the components. The intercomponent communication is controlled through the security. So the ability, in fact, every time you perform an intent, you actually have to tell the manifest which screens, which activities, which class is going to be involved. And it's usually at the class level, the application name that can participate from an intent perspective. Otherwise, you can't. I mean, just imagine everything is turned off by default, and you're basically turning stuff on individually. This component here is allowed to communicate with this component here. So you're basically telling in the manifest, you're telling the Android runtime environment that the intent is legal between those two components. Each application runs as a unique user identity, and which lets Android limit the potential damage for programming flaws as well. So the application itself has a unique user identity. So it's not really running in terms of a generic. It's unique. So you can identify it and know which application is doing what, essentially. So in terms of the enforcement, we have the intercomponent communication, which is a reference monitor. And then we have the Android kind of in the middleware that kind of sits in here as I wouldn't call it a port sniffer, but it's an application sniffer. It's checking in terms of trying to make the components actually connect back and forth. And then we have user here, we have app 11, app 12, app 4. These are just different apps that would run from different user perspectives. So think of these as different shell environments. That's would be the Linux or Unix equivalent to that concept. And then we have the location, the data friend tracker, friend viewer, data contacts using a contact list or a contact application, probably through a content provider. And here's would be the application level. And then we have the friend tracker application itself, which would be running from a different class. So 1, 2, 3 different classes, 1, 2, 3 different users, 3 different environments, 3 different security levels, 3 different manifests, essentially, 3 different components, all running on the same middleware. Not really communicating amongst themselves. Instead, they're communicating back and forth between service providers and broadcast receivers and things. So here's an example for protection. The security enforcement occurs in 2 different places. Each application executes its own identity, so each application is separate. This is why applications can't share databases. They don't share files. They don't share resources of any nature, and they don't communicate with each other. So an application, if you think of it sort of, I don't like to use the word user, but if you think of it as a separate mode in itself, almost like a separate login or a separate shell to the Android environment. And then you know that you've got complete isolation going on there. So allowing the Linux to provide a system level isolation. And Android middleware contains the reference monitors that mediates the establishment of the intercomponent connections from one application from here going up to one user to one application kind of component connectivity. So the core idea is security enforcement, labels, assignments to applications and components, identifying components, labeling them, the reference monitors providing mandatory access for the MAC enforcement, and how applications access components for MAC addresses and all sorts of different things in terms of the ICC that's going on, the intercomponent communication. And access to each one of the components is restricted by assigning it an access permission label. So those permission labels that you're setting in the manifest are putting an ID on something, telling the middle, just call it a runtime environment. The slide set calls it a middleware. But tell the Android middleware / runtime environment that this ID is accepted to talk with this other ID. And these IDs are associated with the permissions that are set, whether it be an application name or whether it be a permission for internet or permission for this or permission for that. You can just drop it off if you want. So when the component initiates the inter-process communication, you don't need anything, right?
There's a previous one with the previous.
Okay, perfect. I'll get it later.
Yeah.
That's okay.
Okay.
Right, thank you. Okay, so when the component initiates this inter-process communication, the reference monitor looks at the permission labels. So that's why if you don't have it, you're going to actually essentially have a crash that occurs. Well, it's not really a crash. It's a lack of a component that's missing, a label that's missing, that it's looking for automatically. And otherwise, it assigns it a containing application. It says this label belongs to this application. If the target component's access permission label isn't a collection, then it allows the establishment to proceed. So if it's this label is part of this application and this other label is part of this application, then all is good and we can communicate and we're going to proceed. Otherwise, what ends up happening is the application closes down. There's not very much air checking that goes on with that. It just crashes, essentially. And an easy way to check that is set up an intent and don't modify the manifest to add the two application names that you're trying to communicate via the intent back and forth with. And then what ends up happening is the app will run just fine until it starts to use the intent. Then it checks the security, doesn't see any permissions, no label, and then it crashes. Which is interesting. But it's not going to come back. Not even in a debug mode will it come back. You'll see messages though. Usually if you run the debugger and you look at what happens when that intent fails, you'll see something like, component missing or no permission. Sometimes you'll actually see the word permissions actually on there. So here's application number 1 and application number 2, and here's our permission labels. And we have our inherent permissions from A, and A is going to be talking through to B and C over here. And maybe these are intents, maybe these are broadcasts, maybe this is just one activity communicating with another activity. And the logic itself, this is the access permission logic that goes on, where it's going to check. So A will check and see, okay, is it there? Does it work? Okay, good. We can talk to you. It's kind of like a traffic guard. Can we go to the left? And they're going to say yes or no. And you go to the left or you go to the right, depending upon what's going on. The Android middleware component itself, the reference monitor provides the mandatory access control, which is what MAC stands for, enforcement, and how applications are basically going to access components of each other and components within the same application. So the basic enforcement model is the same for all components, and component A's ability to access components B and C determined by comparing the access permissions, labels A and B, B and C, or the collection, which would be part of application number 1. The problem is you can't turn it all on or turn it all off. You have to actually list the components and establish the labels for each one of the identifying things. So in terms of the security enforcement, just to recap a little bit, assigning permission labels to an application is going to be specifying the permission domain, making things aware about who can communicate with who, Assigning permissions to the components in the application itself specifies the access policy to protect its resources. So even though it's within inside of the same application, you still have to set those permissions. So, in the Android policy enforcement is mandatory. You can't turn it off, which is interesting. All permission labels are set at install time and can't change until the application is reinstalled. So, and in fact, you can see what permissions are set from the information about each one of the applications. If you go into the settings and start looking at that. The permission labels themselves and the mode only restricts access to components and doesn't currently provide information flow guarantees. It's it's using sort of a UDP protocol actually. So when the intent receiver is going to receive information from the person who's providing it, the page that's calling it, it's going to send, first name, last name, address, a bunch of information to it. Hopefully it gets it. There's no guarantee. There's cases in which it doesn't get there because there's a congestion, traffic through the, something having to do with the middleware management, perhaps. So it doesn't flow. Intents don't work over internet connections or even over providers. It's more of a middleware issue. Equivalent to the JVM, actually, having things registered so that they can speak to each other. So, and in fact, you get the same thing with some of the Java non-Android environment. You get the same kind of permissions, policy files, and permissions that are set. It's actually kind of the same concept, just applying it to different features of the environment for the Android. So security refinements, public versus private components, and we see this from a programming perspective. Applications often contain components that another application should never access. Those would be private. For example, components related to password storing. And the solutions define them as private components. This significantly reduces the attack surface for many different applications. If something is private, it's only held within the class. Just like other forms of programming, however, in Java, there's people that make everything public. So then you can, for inheritance purposes, for interfaces and things, you don't have to worry about, access privileges. It's always open. But from a security perspective, private actually does kind of seal things off, make it only visible inside of the class. So if you're hard setting a piece of data, an IP address or something like that, which you probably won't be doing, hopefully, but maybe a password or something, that you can make private. And then you can't get that from another class that tries to use it from within the application. Implicitly open components. So at development time, if the decision to access permission is unclear, the developer can permit the functionality by not assigning an access permission to it. If you don't do that, well then you're opening it up. Only works in development environments. So if a public component doesn't explicitly have an access permission listed in the manifest, then the Android permits any application to access it, which is the opposite of security. Broadcast intent permissions. So sending an unprotected intent is a privacy risk because information can be spread. Information without control can leave one app go to another, or one system go to another. So the API for broadcasting intents optionally allows the developer to specify permission labels to restrict access to intent objects. And that's pretty much what you're doing when you're listing intent applications. So this class is going to be able to communicate with this other class, and you're not basically making it so that every class can communicate unless you say no. Which is the opposite of that. Content provider permissions. This is normally something people also have to struggle with occasionally. So if a developer wants his application to be only one to update the content, but for other applications to be able to read them, you can set it that way. So it allows for security policy assigning read-write privileges. And so you can, the application can access the contact list, but it can't update it. Or can access a particular file but can't read it, but can open it because the application needs it or something. And And then we have protected APIs. So not all system resources, for example networks, are accessed through components. Instead, Android provides API access through it. So we can load on security APIs. So the projects themselves, Android protects the sensitive APIs with additional permission labels checks. So must be corresponding labels in the manifest file to use them. This is sort of like the API for Google Maps as an example that has a map key. You specify the API in the manifest, you give it a map key on the web view, and you essentially open it up so it can actually access the restricted sequence of events. So if the key matches, then it can utilize the data. And basically what the key is essentially doing is making it so that the information you're getting from the content provider is only being used by your application. And your application is being identified by that key map. And then so if another application tries to use the information that you have received, it can't because the key's not going to match. So most people look at it from a perspective of, well, how do I get this to compile correctly? And how do I get it to run correctly? And then they go, oh, well, that's what I need the key for. And then, but it's really actually for protection against you in the outside world. So it's like public and private key concept. Keep everything safe in terms of who's accessing whose information. So permission protection levels provide a means for controlling how developers assign permission labels. Signature permissions ensure that only the framework developer can use a specific functionality. Only Google applications can directly interface with telephony APIs, for example. So you can actually add a signature to it. You can do this as well on the iPhone platform to make it so that other people can't use the services, can't use the content provider because that's personal sensitive information perhaps. You don't want them to borrow it or to use it. And also the concept of pending intent. So a pending intent means that a developer defines an intent object to perform an action. However, instead of performing the action, the developer passes the intent to a special method called a pending intent object that is corresponding to the desired action, and then that one simply is a reference pointer to pass to another application. So it's basically putting the control over into a separate object to check for the security and make sure that everything's set up properly in terms of the intent communication. Pending intents allow applications included with the framework to integrate better with third-party applications. Actually, it sort of streamlines it a little bit as well. Sort of a queuing process versus a direct one-to-one connectivity. So in terms of lessons for defining a policy, Android security policy begins with a relatively easy to understand MAC enforcement model. Number of different subtleties to it. Refinements make it difficult in terms of application policies, but not impossible. The label itself is merely a text string, but the assignment of the application provides access to potentially limitless resources, if you think about it. And it's just a text stream that's providing you that access. In fact, it's not too hard to set permissions. It's kind of straightforward, actually. All right, so part 2 of today's is on the menuing system and sensors. And this I pulled up because I like the integration of the source code examples. And this was taken from a Stanford Open University website. So it's a pretty decent source, pretty decent, kind of a clear screenshot in terms of this presentation as well. So what we've done in a couple of the other apps that we've built so far in this class is kind of put these menus together, but we never really looked at dialogs. Actually, we haven't looked at dialogs at all. Actually, I can show you a dialog from the mobile ITU app that I'm putting together. And I'll wait until last before I show you that, which is show you basically how easy it is to actually put together little dialog boxes, little menus and things. Because inevitably what happens is you've got to have the user choose and select from something. So here's a simple menu example for which we've got 3 items that are showing up, or 2 items. And we're going to basically put some items onto a screen and then have the user click on the item. And then we're going to say, item number 2 was selected, color is green. And So if you take a look at it, the menu itself is on the bottom of the screen. This would be the options menu. And the options menu's got the red, green, and blue. When you click on it, you can actually see the colors, or see the information that comes up. So this would be an on-create options menu. And the interesting thing is that the menu itself has a listener that's associated with it. And the listener is the one that's going to basically giving us our on options item selected, which is going to pass the menu item that was actually selected from the listener that goes into this method call. So the source code for this is quite simple. And what we've got here is an on-create options menu down here. And we're using a menu inflator. And the menu inflator is going to get this menu 3 items from this XML file. So there's actually 2 ways of doing this. You can write the menu yourself without using an XML menu, or you can put together the XML menu, use a graphical menu editor tool for it. You know, put the little icons on there and stuff. It's actually not that. I mean, it's just like the interface builder for the main XML file. But this one has menu options, so you can actually create this menu option, create that menu option, or you can do it programmatically. And not do that at all, just create the menu. In this particular case, this one is using an XML file. And so the XML file is out here. And actually, I can show you both of these done in a similar fashion by, let me open this back up again. I'll show you both done programmatically, because it's worthwhile to see, only because the statements are pretty much the same, but are you going to inflate an XML file? And I believe we talked about inflating files and assigning resources, creating a local button and assigning code that came from a GUI item to that local button and using that local button in our class file as a resource. In here, I have got, I know I've got it from here actually. Nope, it's actually going to be an options menu. Let me see if I can make this a little bit bigger. Let's see. Make this a lot bigger. Get rid of this down here. Here we go. So this is an options menu. It's an on-create options menu, which is going to give us 2 options, a new text node or a new audio note, which is going to show up when you press the menu button, and it's going to load a couple icons on there as well. But this is done programmatically. It's not done through an XML file. You can also create a menu through an XML file. If you do it that way, it's going to show up in the menu directory, which is where you're going to put it. And if you click on the menu, that XML file, you see it's not as hard as the source code. It's more menu driven. So we would have, as an example, lessons, assignments, stuff like that, which is another context menu, but it's set up through the menu builder, or well, it actually is referred to as the menu builder, but I don't really call it very much of a builder. Just like the other XML files, you can click on the XML here, and you can actually see the items added on. If you do it this way, you're going to use the inflator to take this menu, get all these values, and assign them to local stuff. If you do it this other way, oops, you don't have to inflate it. And instead what you're doing is just programmatically adding items. In fact, this actually should be a 1. That should not be. I just saw a typo here. I'll just change it now, actually, to make sure I save this. And then here's the listener that was added to it, which is further up. So the on create options menu, and then the on menu item selected. And the on menu item selection is going to say, well, if this is insert ID or audio ID, then we're putting together a simple case switch kind of thing that says, on here, open up this function. On here, run that function. So it's kind of a quick way of creating a menu and then taking those menu items and performing a function call when one of them is selected. And then on menu item selected, you're going to return super, which is going to take it back up. So, and then here's another. So you can see I've got on create context menu, and then there's an on create options menu. So the options menu is the menu that shows up on the bottom of the screen. The context menu, if you put your finger down and hold it long enough, this context menu comes up. It's on a long press. There's other ways of bringing it up as well. In fact, you could create a context menu and then you could create submenus in the context menu, and you can actually have, depending upon the length of the press, have different menus actually show up if you wanted to. It's a little bit difficult to orchestrate that. Not advisable. So unless, you know, when you press on something, you press on an item essentially. If you press on it once, it'll open it up. It'll run a select. The other one will open up the context menu. Context menu in this particular case is, see, now I got the numbering right here, which is good. Adding 3 items. So menu adding this, menu adding that. You could put a submenu in here, which is one of these items would actually be another menu. So you click on another menu. When you see this, when you're setting preferences, when you're setting settings in an application, when you want someone to be able to cut, paste, modify, select all, text editing. So the on menu select item selected goes with this one here, and then we have the on context item selected, which you might imagine is very similar. Here there's only one item. Actually, there's only one item here that's going on, because we have the case here for which we have an adapter that's going to get the menu item that was selected, and then it's going to run this function here for a delete. Essentially, it's going to run a. This is going to be a method called delete note that's going to be from another class. So let me go back to the. Oops. That's the wrong one. Here it is. This is the one I was looking for. All right, so programmatically, that was another little bit example here. This is an on options item selected, which goes with the on create options menu. Very similar to the code I just showed you a few minutes ago in terms of another example. And here, instead of using a case switch, we're using an if else. So you definitely have the freedom. I actually personally think the case switch is a little bit easier from a programming perspective because it's a little cleaner. Not as many opening and closing brackets and stuff like that. But plus, it's easier for me to see it sometimes. But anyway, you want to implement it, you're just basically testing for the different cases. Was it item number 1, item number 2, or item number 3 that was selected? And so the submenu here looks like this, where we have a green sub A and green sub B, and this would have come from, let's say, for example, a press main menu item. So the submenu itself, here's the the XML file for it that's creating it using a menu builder. So we have menu, and the menu is going to have item A and item B, and this is really what's referred to as a submenu. And if we look at this, then we have item number 2 selected, color's green, color sub 2, because we've picked it. So it actually keeps track of the hierarchy of the menu. So in here, when we had 1 selected, it knew it was this top level hierarchy. If we nest another menu inside of that menu as a submenu, we get everything. We get this submenu, and then we get this item that was selected. Sometimes you want to do that because you've got a bunch of features you're trying to, settings. You want to do Wi-Fi, so you put it here. And then in the Wi-Fi section, you've got this, this, and this, and then in that section, you got this, this, and this. Great way of keeping track of where you're at is to create the submenus and put them in there. And nest them in a hierarchy, because then you know where you're supposed to be returning to. So, but the XML file is kind of trivial. This was done with the menu builder again. So in terms of menuing items, unless you've got the context menu and you've got the options menu, and those are basically your only choices on the Android. You can come up with your own menu. You can come up with your own dialog box if you want as well. That's entirely possible. Sensors and actuators, another kind of component here. So the sensors itself provides information about the device and its environment, senses signals, incoming calls, location sensors, all sorts of different things. So we'll ignore the camera and the microphone for now, but you can actually get camera and microphone sensors as well. So sensor types provide the most. Application phones themselves are going to be accelerometer for acceleration among 3 different axes. So the location, or the, what do you call it, the movement. The gyroscope orientation, 3 axis orientations or headings that are associated with that. Light, ambient light sensor, you know how your phone always gets bright when it gets dark. Actually, your computers do that nowadays too, or the Mac does that, I should say. Setting appropriate screen brightness for different, and you can have your app do this actually, because your app can use the sensors. You can essentially do that. Magnetic field, the 3-axis magnetic fields for car navigation, system startup, stuff like that, to give you location information. Pressure exerted on the device, proximity, distance between the devices and the target, usually electrical fields themselves. Turning off screens when near ear, so it doesn't accidentally press buttons or something. In terms of, you know, when you're making a telephone call, if you haven't noticed, your screen actually goes dim. Your screen will go off when it's up. If your phone is set to use that sensor. If the sensor's turned off, it's not going to do that at all. Or if the application you're using is not designed to do that, it's not going to do it. Temperature, some meaningful temperature stuff for battery, overheating, stuff like that. Battery level kind of works, so there's a little question mark there. What is the battery level? Interesting. In fact, you can wear the battery down checking the battery level. It's like the chicken before the egg thing. I had a good battery before I tested it 12 times. The battery's low. Actuators. So they provide feedback to the user. So beyond views, you can program them. So you can access lights on the device, a notification bar, which I believe next week we're going to talk about notifications, a vibration, force feedback, movement of the phone, drops the phone, turn the phone off kind of sensor. We have sensor managers. So just as we have content providers, we have intent managers, broadcast receivers, we have sensor managers. They manage all of the sensors. So it provides an interface object for you to work with through a request sensor information. So you ask the sensor manager. So you create an object of the sensor manager and you find out, well, how hot is the phone? What's your current temperature? And how long have you been turned on? Or, you know, how much battery life do you have left? So there's more than one physical sensor that can be provided particular information, different types. So users of the sensor manager parallels the location manager usage that we've seen before with the mapping. We're just basically getting the location of the phone from the location manager. So user programmer requests the location manager to provide updates in terms of, provide me with updates every time I walk, every time the phone moves. Actually talks to the GPS, cell tower, wireless service, gets the data for you, delivers it for you. Well, so does the sensor manager. Does the same thing as the location manager. So getting access to the sensor manager, you make an object. Here we go, sensor manager. Sensor manager is equal to new. Get system services, context sensor service. So you could probably play around with this, write a little Hello World app that made an instance of this object and got all of the information that was available and printed it out to the screen, and then there's a million of those apps out there actually. So you can probably find one that's already made for you and download it and install it. In terms of what's available on my phone, you can figure that out as well. You can request the sensor manager to provide a list of sensors available on your phone. So instead of having to do them manually, you can find them by yourself going type all in terms of the sensor. And that's going to come out with a list. You can load it into a list box, and you can see all of the different information associated with it. So you can actually make it so you press a button, and it essentially shows you more information about the information. So information sensors are given a type. This book actually, where the slides it actually comes out of, is Android for Programmers. And I ordered a copy of this book because I'm going to use it next term. The next time I teach this class. But the book itself has a lot of resources in it, and it's like an encyclopedia. It's got, in fact, maybe by as soon as next week, I'll have a copy of this book I'll pass around and show you if you're still looking for a book for this particular course. I don't like the one that I had been previously using, but this new one is by Deedle and Deedle, which is really good because they make some really nice stuff. And there's a program by example, so it's full of about 5 or 6 different apps in there, sample apps that go through each one of the features, which is nice. So, but anyway, that's the book itself has a whole list of the sensors as well. And so sensor listing from a sensor example here, what's available in the emulator. Accelerometer, well, not really. Kind of, sort of. If you go through the debugger, as we saw, the DDMS manager, we can sort of send information to the emulator. As we saw with the mapping program, we sent latitude and longitude for a location and made a fake location information. We can also set orientation to landscape, or we can set it to portrait mode. We can do all sorts of different things to simulate the sensors in the emulator. What's available on a Motorola Droid? A lot more. See, a little bit here, a lot more here. So the real device itself is where you're going to need to start testing. If you're going to write applications and you want to test them and they're using sensors, then you're going to probably want to test it. In fact, if you're writing a mapping program as well, it's easier to test it on a real device than it is to use the emulators. Any emulator doesn't really work well. Registering to listen for events. So we have a sensor manager, which sensors we want to listen for. Again, much like the location manager, I want to listen for GPS events. So we go to the sensor manager and we say, listen for this type, listen for that type. So get the handle of the sensor of interest by creating a new sensor object, instance of that object sensor, and then ask for information about a particular sensor and then get updates for each one of the sensors. Eventually unregistering the updates is done by doing an unregister listener versus a register listener. And you're thinking, well, why would we want to unregister it? Well, it eats up resources, makes your application run slower. If you register a sensor, you're no longer using the GPS features anymore. You're no longer using the motion or the heat sensor anymore, but you're still pooling it for updates. So, waste resources, makes the phone run slower. So unregister it when you're done using it. Registering to listen for events, also another thing that you might be interested in doing. So the listener, the sensor, the update rate, you can listen to all sorts of different things. So who's listening to what? How fast are they listening? Well, you can find that out as well. You can get a list. The sensor has a list of all people who are listening, applications who are listening. So some applications that you've loaded up and you notice everything's running slower, you can check the sensors. Actually, you can run a diagnostic app that checks the sensor, returns everything back, and sees who's doing a constant update every 10 minutes. Who's doing this, who's doing that, which is probably unnecessary. So maybe once a month or something the app can update itself, but it doesn't have to do it like every hour. So the listener itself, usually the class, this. The sensor from previous line of code, sensor is going to be equal to sensor manager, get default sensor from some sensor type. Update rate, one of the sensor delay, fastest, delay game, delay normal. So it's an example of how to pull all this together. Well, there's an example coming up very soon here. How to handle the update from a sensor. So it's nice if you've got a sensor that's you're checking and it's we'll use the location because it's easier to figure that out because it's usually event driven. But let's say you want to deliver a piece of information about you have a sensor checking on the battery and then the battery keeps changing. So we've got updates that are happening because we're checking it 12 or 15 times and we're deliberately wearing it down. So what's going to happen when the update comes through? Do we want to print it to the screen? Do we want to log it in a file? So handling with the event is interesting. Employing a listener pattern, as we've already seen for views and location information. So here's a public interface for a sensor. Event listener that's going to look at, see what happened when we have an update, perform something. So two functions that are called reporting a change in accuracy or reporting a change in value. So sometimes the accuracy might be, the sensor can no longer sense. It's past a certain temperature. you're too far away from a signal, you can't sense anything anymore, then that would be a change in the sensor itself in terms of its accuracy, and then the values themselves that are coming back. So here's some examples from some sensor events that contain what information they contain. As an example, the accuracy, the sensor, the timestamp of when the information was obtained, and then the values that are associated with the information. The values are going to be specific towards the event that you're listening to and the sensor that you're interested in following. Note that these are all public variables, assuming that the sensor event variable called the event. You don't have to go you don't have to call event.getActivity. You can just do event activity because they're registered events that you can actually run. Value arrays will be filled with the appropriate information that comes back. If more than one value comes back, it'll come back in an array, which is nice because then you can catch sort of like a stack. You can catch all of the information that's coming back from the sensor. You can place more than one spot, perhaps. Here's an example of a sensor, and this is you can cut and paste and put this into a sample and run it. It actually works. What this is going to do, it's going to do a sensor test activity. And it's extending or implementing sensor listener. We didn't look at it before, but the other one was looking at extending. Well, they're all extending activity, but they can do options menu listener, select item selected listener, all sorts of different listeners that you can implement. So we have a text view, we have a sensor manager object, and so obviously we're going to make an instance of the sensor manager object, take all of the values that come back, put it in the text view. Simple. So the onCreate is going to it's going to take a main.xml file, inflate it so we can get the values that are associated with it, and so we can read and write to the interface. We're going to define a text view, and the text view is going to be this text view. It's the only thing on this interface that we've created. We're going to make a new instance of the sensor manager object. So it's a standard way of creating one, and then we're going to do a sensor service because we want to get all of the services that are coming back out. So this would be the context. And then these, you don't memorize these, you get a book and you look up all the different sensors that you could possibly check on and all the different things that could possibly come back. And then we're going to create a list, and the list is going to have all of the different sensors, so list adapter. And then we're going to use a little loop here to go through the list and find and print them, essentially. Add them to the text view. So line by line, we're going to append, and create a string out of it, and put it in the text view. And then we're going to start the listener. So the text view is going to say starting listener in the light sensor. And then this is going to be all of the light information that comes back out of it. So then next it's going to print out from the sensor, light sensor. From the sensor manager, get the information from the light sensor. And the light sensor is going to give us the type of the light, and then the delay, normal. Then on destroy, we're going to unregister the listener, so we don't have that service running in the background there. And then on the sensor, when something happens, then we're going to update it. So we're going to find the distance, which is going to be equal to the sensor values, see how many sensors we have got come back, and then update the text field with the distance plus the flux. So it's basically telling us how far away, actually it's supposed to be giving us light sources, light sensing. You can actually do a on-accuracy change, which means, if, let's say, for example, the sensor is no longer bringing back the light information, when we turn the lights off, it's completely dark in the room, the phone can do something else. It can unregister itself and turn itself off, or it can print up a little status message or something. So another example for the accelerometer. So we've got the top, the down to the bottom, and we've got essentially the plane in which the phone is residing in. If you think it from a computer, actually it's more of a geometric kind of perspective. So imagine a device sitting on a table, and we have the XYZ coordinates of how it would sit in the plane of a table. X-axis is the lateral movement, the right-left values. So plus values are moving to the right, minus values are moving to the left. So if you imagine holding something around, not bad for games. if you have a pinball game, if you've got a ball, and you want to use, this is the sensor you're getting. Accelerometer is what sensor you're using to orchestrate how the ball is going down and hitting pins or something, or maybe it's a bowling app or something, something where you've got movement and you're adjusting the phone to make this game or something happen, paddle or something. The y-axis is the longitudinal movement, the vertical movement is on the z-axis, so we've got an x, y, z three-dimensional plane essentially that we're working with. Built-in contexts in the sensor manager class that you can use to normalize some of these as well, including the gravity of the Death Star, well, a game, what's that associated to. In fact, it's interesting that they call the orientation the gravity. So the gravity in the Android term is when you set the gravity to the top, if you're talking about text, it's going to show up at the top of the box. If gravity is centered, it's going to be in the center of the box. Gravity bottom, which is interesting because it kind of comes from this concept of why they call it gravity. I would have called it orientation maybe. But, kind of like how Microsoft Word, you have left align, right align, justified. Same concept, but it's gravity. So sensor example here, continuing, attempting to detect or being picked up pick up or falling. You can sense for those particular events. Reading from accelerator comes quickly. Average last 10 readings compared, well, 9.81 plus or minus a little noise. So. And that is actually kind of pretty quick in terms of the average reading. Here's an example of putting it all together, and all this is going to do is give us the information. Naturally, you can't do this on an emulator, so you would have to install this on a device that actually had a sensor for accelerometer, so you can actually move things around. In fact, you can do this in coordination with a mapping application. Well, the location manager is going to update the sensor anyway for you. It's going to update the accelerometer for you automatically because it's going to know where you are. And it's not going to update the accelerometer, it's going to update the location. Location manager will do that. So you could essentially change the view associated with particular orientation. As an example, if the phone went on its back, you could show the ceiling. If it's up on the top, you could show like a face-on view, or on the bottom. You can adjust, kind of make a 3D reality thing out of it if you wanted to. Alright, so what we're going to do here, this is the onCreate. The onCreate's going to, again, use a main menu. Here we go, make that a little bit bigger so you can see what I'm talking about. It's going to use a main.xml file, and we're going to get the context view from create a text view local object that we're going to read and write to for the text menu. Create an instance of the sensor manager, get the service from the sensor service, because we're looking at the accelerometer, this particular type accelerometer that we're getting from sensor accelerometer. It's going to be from a new sensor. Ask our sensor manager for the sensor type accelerometer, and also ask it or register the listener, and that's pretty much all we're doing here. And on sensor change, register to change. So we're taking the text view and we're going to copy on a change. We're going to copy the values that we're getting. So regardless of what sensor you're actually making an instance of, or what sensor type that you're running, you're always going to use the concept of values that are associated with it. And the value method returns the value, single value or multiple value, depending upon what you're getting back from the sensor. Because sometimes we have some sensors that have values that are Boolean, true or false, and then it would just be value. So true or false would be like, are you connected to the internet? No. Yes. Maybe. I don't know, there's no maybe usually. Alright, so let's see. The rest of this code is essentially going through a little, on a sensor change, do something. So it's the last 10 vertical size. Last 10 vertical move, remove this, add this, modify the output essentially that we're looking at. And what we've got up here is the output from the first one. Holding it in my hand as an example, sharp upward motion. We can sense that the accelerometer sensor has changed its opinion of where it currently resides, and we can pick up that sense. And we can go like this. Put me down. had it in your hand and then you put it up this way or something. So basically, good for gaming, good for game programming, because you can actually create some realistic kind of activity, and upon the activity you can move an object on the screen or something. Actuators, so that's the concept of the accelerometer and the sensor of the accelerometer, which is what that's about in terms of how to use it. Actuators are another one. Actuator provides feedback to the user. Beyond the views and the activity, we can access status bar, and we can access extended status bar, lights on the device, vibration, force, feedback, ringing, icons, messages, all sorts of different status indicators. So you can employ all of the notification framework as well as some of the independent frameworks as well. But this would be for the notifications. So an actuator is basically going to see, did something happen? Was there a new action that occurred? So hardware lights, where a droid has one with multiple colors. Okay. We have the status bar on the top. This is, if you've never seen a droid phone before, this is a good example. Extended status bar, notifications that show up on the top. Usually you take your finger and you wipe it down. Believe it or not, there are some students in this class who have never seen an Android phone before. Okay, if you've seen the emulator, you've got a good thing, but you probably, actually there's notifications that appear on the emulator as well. If you ran the text message app, you saw the SMS text message application we did in here, you saw the notifications work. As far as the actuator sensors, so employ a notification manager. So just like the location manager and the sensor manager, the notification manager tells you when there's a new notification. So if a new notification shows up, you can ring a bell, play a song, I don't know, push the notification, open it up, run it, process it, deal with it automatically if you wanted to. Notification manager, notification service is the context from the sensor. Same thing as before, but we're creating an instance of the object of the notification manager, and it's going to be the get system service notification service, which is the same service on every single provider. In terms of the actuator for the status bar, notification status bar employs, that's the status bars on the top there. The icon to be drawn, the Tinker text perhaps to be shown, time of the notification for appropriate ordering in milliseconds. Do you want it to stay up all the time? You can actually make it a really irritating notification that never goes away. That's up there all the time. Extended status bar employs application context, the title, pending intents, anything information associated with that can be launched from the notification pressed. And you can set the intent in a pending intent as null if you don't want to launch anything. To use it, you create the notification by creating an instance of the notification objects, and you create the notification manager notification object to get the service, and you talk and read and write to the service, and you send notifications to the sensor. So you add the notification information to the extended status bar, you send the notification manager with an intent reference ID, and eventually cancel the notification using the same reference ID if you're going to cancel it from within the application, or you can allow the user to cancel it. So to create the notification, here's an example. I'm just going to give you the kind of the snippets, essentially. Notification is equal to new notification. Oh, that's interesting. Using an icon, a text, how long in milliseconds should the notification take to be there? Should you wait? So when's it going to arrive? You add an extended status bar information to this by setting the last event information. You can send a notification manager. So to notify the notification manager, say, hey, I got a notification for you. And eventually cancel a notification through the notification manager. So if you don't want to send it, if it's already been sent, you can cancel it or remove it from the notification bar. So you can write an app that actually just goes to the notification bar and removes everything for you automatically. Turns off the notification. So here's a little bit of source code for this, and this is the notification up here that has an icon associated with it. A lot of people are using icons actually. in the old days, nobody would put an icon up there. But now you can see classic icons for certain things like updates, the little update icon and stuff. Which you'll get a notification if your phone has done something. The update manager has gone out and updated something. You'll see a notification. When you swipe down the notification, you see the button was pressed. If you press on the button's going to actually swipe down the notification for you. Which is kind of a senseless application, but it serves its purpose in terms of an easy example. So class notification test activity extends activity, implements the view on-click listener, because we've got a button here, and we're going to use the on-click listener for that. And this is actually the one way of doing, I just forgot to mention something here actually earlier when I was talking about the actually I was talking about dialogs at that point. If you don't want to write an on-click listener method, you can actually just implement it, and it'll implement the default on-click listener by extending that class, and it would be an interface class that's implementing. So here we're just making an instance of the object for the notification manager, and we're making an instance of an object for the button, and a value was a pressed or not pressed, a Boolean value. And setting up a notification ID is 1. This is just an integer. So on the create, we're going to use a main XML file, inflate it, populate the local variables, the button with the information, and then we're going to run the location manager, create the instance of the object to get the notification service, so context notification service. And then on the click of the button, we're going to use if and else's here. We could use a case switch if we wanted to. Same thing as before in terms of the on-click activity. Notification equals a new notification, star, button pressed. So we're going to send a draw is the image. Drawable is usually an image associated with an icon or an image. Star is the name of the image. And put the button pressed as the text and send it for current time millimeters, whatever it happens to be. Just send it now, essentially. And then if it's set the last event information, basically again, clear it, make the button pressed, the button updated, essentially, and send a pending intent that says when you press it, it's going to update it. So it's going to essentially put that little information out into the text box that's on the screen. And then press is going to be equal to true, and then the text on the screen is going to be equal to on the button it says press to cancel notification. So you set the notification and then you cancel the notification via the button press. It's on the box. The button press is over here. Press to cancel notifications. This is the after. So we pressed it to start it. We put it up here. Press to cancel. Press it to cancel. It'll remove the notification. So, not a bad example. Actually, just demonstrating how to access the notification itself. Yeah, the rest of it's pretty trivial. It's just a simple example. Notification bells and whistles. Notification bells and whistles, such as lights, sounds, vibration, can be associated with notifications. So you can have a text message that plays a sound or something, or turns on the lights on the phone when the notification comes in. So build a notification using the approaches that we've seen in the previous slide here, and then associate the extra features with it. So using the same code, you're just associating all of the audio and the visual and the vibrate the phone kind of thing that goes on. In terms of vibration, this requires permission to vibrate. You actually have to set up, and this goes along with what I was saying earlier. Use permission vibrate. I have to turn it on. Otherwise, we can't vibrate the phone. Because otherwise, it would be a security thing, right? What would vibrating the phone do? Actually, it would probably run your battery down if you vibrated it for too much. So, define an array of longs which contains times to vibrate on and off. So, set the notification.vibrate variable to the array specified above, and then you essentially the .vibrate is going to turn that on. If this permission isn't set, your phone's going to die. Or your app's going to die. It's going to fail on you. Sounds are done in a very similar fashion. Any sound can be associated with a notification. So set a notification.sound variable to the URI of the location on the phone that points to the sound. So whether it be on the SD card, whether it be on the internet, it depends on where you're going to pull the sound from. You can access the default ringtones through the ringtone manager class. So you can play your ringtone as an example. Actually has separate defaults for alarm, notification, and ring. So it's kind of a, just using a dot sound to call the method for the sound. Lights. Set the color of the light can be construed through RGB. So notification LED RGB color dot XXS to set the color. So the length in milliseconds, the on, the off, the flag show lights to basically set essentially lights that are going to be set when the notification arrives. So it sets a flag to show the lights. Again, wears batteries down on the phone, but some people like to do this with their notifications. So you can do all sorts of different, have bells and whistles that are associated with it. So, that is all you ever wanted to know about sensors on the phone. So today we covered the sensors, and then we covered security as well. It became late, but that will be a good time too. That will be all for today. So, unless we have questions, comments, or concerns. We have Android seminar, Android workshop this weekend. March 31st, the last day of March. Saturday, if anyone's interested. Looking for volunteers to help out during the seminar as well. So. Alright, that's all for today.